Hi everyone, we're going to find the critical numbers for f and find open intervals where f is increasing or decreasing, and also apply the first derivative test to identify all relative extremum. And the first thing I'm going to do is go ahead and apply the first derivative test. So this will be 2x plus 8. We set this to 0, and when you solve this for 0, you're going to get x equals -4. So this is our critical number. Now, we're going to go ahead and do test intervals for this. So since it's a polynomial, we have f of x equals x squared plus 8x plus 10, and our derivative is 2x plus 8. It's a polynomial, so we know that our domain usually is all real numbers, but since we have a critical number at x equals -4, we're going to divide our test intervals with -4. And then we're going to go from -4 to infinity. And basically all this means is in our derivative here, we're plugging in small numbers. So if I plug in, say, -5 for this one. So if I plug in -5, this is going to be -2. And if I plug in -6, it's going to keep decreasing. So our the sign, all of our numbers here, our sign is going to be negative for the derivative. On the other hand, when I plug in, say, -3 for this interval, that equals +2, and if I keep plugging in numbers bigger than -4, my derivative is going to be positive for this interval. So our conclusion is, since this is negative, this is decreasing interval, and this one's increasing. And then all we need to do is write that it's increasing on the interval -4 to infinity, and decreasing on -infinity to -4. And our relative minimum well, you're going to plug in -4 into our original equation, and when you plug in -4 and you plug it in here, you're going to get -6. -6 occurs in this region, so this would be the minimum. Okay? Thank you. Have a nice day. Bye-bye.